Today's lesson is on exponent rules and simplifying monomial expressions. So first we need to talk about exponents. So whenever you have an exponent like this b to the n, the b is called the base. This n, the little n that's kind of high, is called the exponent. If you put them both together with the base and the exponent, we call that a power. Okay, so for example, if we have 5 to the 3, the 5 is the base, the 3 is the exponent. What the 3 exponent means is it's saying that there's 3 copies of the base being multiplied. So that's 5 times 5 times 5, which is 125. So the exponent, which we used the letter n up there, of a number or an expression indicates how many times the base is multiplied by itself. So b to the n is b times b times b n times, and that's what b to the n means. An exponent is just repeated multiplication. So next I want you to evaluate the following expressions. So when I have 4 squared, that means 4 times itself 4, or 16. Now notice on the next 3 we have another sets of 4 squared, but we have negatives in different places. We need to discuss what happens when the negative's on the inside of the parentheses and when it's on the outside, and what does that mean. This next problem students usually like quite a bit. They can see that the negative 4 is inside the parentheses and it's being squared, so they write negative 4 out twice and they multiply it and they get positive 16. Students usually like that one. Now on this next problem, where the negative is on the outside, what this means is we are squaring the 4 first, so it's 4 times 4, but we have this negative out in front. So you can either think of it as like a negative out in front or like a negative 1 times 4 times 4, because in PEMDAS the exponent becomes before multiply, and because this negative is not associated with the 4 like it is with the parentheses, clearly the negative is with the 4 inside the parentheses on the second problem, but on this third problem the negative is out in front, and what we have decided that means in notation in mathematics is the opposite of 4 times 4. Now 4 times 4 is 16, and then the opposite of, or negative 1 times, is negative 16. So notice that these two answers are not the same when the negative is placed in different spots. So let's try to interpret this one. We have a negative on the outside and then we have a negative on the inside. Well, this negative on the outside, I'm going to do this one in red. That's just going to be red. Now the parentheses has a negative on the inside too, but the parentheses is being squared. The little exponent only applies to the thing immediately before it, and the thing immediately before the squared is the parentheses, which includes the whole thing. Like on the last one, the squared only applied to the thing before it, which was the 4, not the negative 4. So in this case we have, let's see, negative, the red negative, and then 2 copies of negative 4. So a negative times a negative times a negative turns out to be a negative. These two multiply up to be positive 16, and we get the opposite of 16, or negative 16. Okay? So notice that these are all a little bit different. Some of the answers come out the same, some of them don't, but you have to think about each one individually. On the next set, we have negative 1/3 to the 4th power. So this means I have negative 1/3 4 times. When I multiply all the numerators, I'm getting a positive 1. When I multiply all the denominators, that's 4 copies of 3, that turns out to be 9 times 9, or 81. So 1 over 81 is the solution here. On the next problem, we have negative 4 squared over 9. Well, there's two interesting things here. because this negative is out in front, that just means the negative's just going to stay out in front. The squared only applies to the thing immediately before it, and the thing immediately before it is actually the 4 only. It does not get to be applied to the 9 because the 9 is not right before the squared or inside of a parentheses of a squared. This one has no parentheses. So the negative stays negative, the 9 stays 9. The only thing that's being squared is the numerator, which is a 4. So that gets me 16 over 9 with the negative still there. Now on the next problem, because there's no parentheses, the answer is just going to be negative. This negative right there just kind of stays out in front. I actually like those a little bit better than the ones with parentheses because I don't have to count how many negatives there are. I just know my answer is going to be negative. No big deal there. And then I have 3 copies of 3. When I multiply that out, that gets me negative 27. And on the next problem, we have negative 3 in parentheses cubed, which means there's 3 copies of the negative because the negative's inside the parentheses. Remember, the exponent only applies to the thing right before it, and the thing right before it this time is a parentheses, and because of parentheses is a grouping symbol, it includes the entire group. Negative 3. Negative 3 times negative 3 is positive 9. Positive times negative 3 is negative 27. Okay, so this is a little bit interesting here. Notice that these two answers were the same, whether the negative was on the inside or the negative was on the outside. So these two turned out to be the same. But up here, when we were talking about negative 4 in parentheses squared and negative 4 squared, those turned out to be opposite. Well, how come these turned out to be opposite, but these two turned out to be the same? Well, it comes down to the number of copies of negative. Up here we had an even number of negatives. So because the exponent was even, we had 2 copies of negative, which turns out to be a positive. Up here, when we had a 3, that was an odd number. So we had an odd number of negatives here. And because I had an odd number of negatives, that means it multiplied out to be a negative. So you have to just be a little bit careful with your exponents when there's parentheses on it. If it's odd, it's going to stay negative, or if it's even, it may turn positive depending on the other things around it. So just be a little bit careful. Our next topic is negative exponents. The rule says that b to the negative n, if we have a negative in the exponent, which is not the same as a negative on the base, but if there is a negative on the exponent, we have 1 over b to the n. Again, where n is a non-zero real number. So what this means is if you have a negative in the exponent, it moves downstairs, or we take the reciprocal. So a negative exponent can be made into a positive exponent by taking the reciprocal of the base. So let's practice that. On this problem, 4 to the negative 2. That's different than the ones we did above that said negative 4 squared. Notice on the ones we did above, we had a negative on the base, not a negative on the exponent. So we're working on a negative exponent this time. The negative on the exponent says I take the reciprocal of the base and I still square. So I have 1/4 squared, which is 1/4 times 1/4, or 1/16. Now this has a negative on the base and a negative on the exponent. Just thinking about the negative on the exponent, that means take the reciprocals, so that's 1 over negative 4, and we're going to square that now. Notice that this negative exponent turned into positive once I turned the base into the reciprocal. When I take negative 1/4 and I square it, that means I write it out twice. Don't forget the negative on both of those. A negative times a negative turns out to be a positive, in this case 1/16. Now on the next problem, we have a negative just hanging out in front. The negative out in front is not part of the 4. So when I have negative 4 to the negative 2, my answer is just going to be negative. And then I have to work out 4 to the negative 2 by itself, okay? So almost like that. Negative out in front is just coming along for the ride. Now 4 to the negative 2, we said I need to take the reciprocal, and I'll keep bringing down the negative in red. So that gets me 1/4 times 1/4 with the red negative out in front, which is negative 1/16. On the next problem, we have a subtraction sign, which means I have to do each one individually, and then I may have to subtract them. So I have 3 to the negative 1, which is 1/3 to the 1, but no one really writes to the 1, so I'm just going to go ahead and take that off. Minus, because there's a minus in the problem, that is not a negative, that's a subtract sign, okay? So we have 2 to the negative 2, so that's 1/2 squared. So we have 1/3 minus 1/4. And now I actually have to do some work. I have to get a common denominator. And the common denominator between 3 and 4 is 12. So I'm going to multiply the first fraction by 4/4, which is a interesting or clever one. I'm going to multiply the second one by 3/3. Whatever you do to the bottom, you have to do the top. And then when I subtract, I'm getting 1/12. So all of those were examples where you take the reciprocal of the base to make the negative exponent into a positive exponent. Now it gets a little bit tricky on this next one. A to the negative 2, b cubed over c to the 4, d to the negative 5. If you keep taking reciprocals and then you're dividing, it gets into be a really hairy problem, and we're trying to make this as simple as possible. So I've come up with a little story to help you on this one. So the story goes like this. You're the landlord of an apartment building. You have tenants on the top floor, which is like the A and the B. Those are tenants, or people living in your apartment building. And you have tenants in the downstairs on the first floor, okay? So you have tenants on the first floor and you have tenants on the second floor. Now, it turns out that when you asked your tenants how things are going, some of them weren't really happy where they're living. So you as a landlord need to make them happy. And so what we do is if we have a negative exponent, that means they're not happy where they're living and they need to move. So like this a to the negative 2. He's living where? Upstairs. Is he happy where he's living? Well, no, he's not. He's got a negative exponent. That's kind of like his attitude. His exponent is like his attitude. So what we're going to do in our story is if we ever have a negative exponent and he's not happy where he's living, well then you move him. So he was living upstairs, he's not happy there, he wants to move downstairs, so you move him downstairs. And now he's happy because you've moved him to where he wants to be. Now b cubed was in the numerator as well. He was living upstairs already. He was a positive exponent. He's happy where he's living. What are you going to do to him? Well, he's just going to stay there. There's no reason moving tenants that are already happy where they're living. Now let's go to the bottom. I'll do the bottom ones in blue so you can see where they're all coming from. So we have c to the 4 was living already downstairs. Was he happy? Yeah, his exponent's positive, so it stays there. And then d to the negative 5, he was living downstairs. And is he happy? No, because he had a little negative exponent there. And then you have to move him upstairs. Now in all of the problems in class that you'll do, or if you do it in a textbook, or on the test, or on the final, all of these problems are going to say, leave all exponents as positive exponents. Okay, so just by moving them upstairs or downstairs, by making them happy or positive, I've completed this problem. I can't really combine any of these terms, so I am just done, but it wasn't done initially because we had negative exponents. Same thing on the next problem. X to the negative 2 is living upstairs. Is he happy about living upstairs? He's not happy living upstairs, so he's going to move downstairs. How about y cubed? He was already living downstairs. He's totally happy with that. You leave him put, okay? There's nothing that you can combine here, but the answer's not quite done like this because there's not anything in the numerator. If we don't have anything in the numerator, we need to put a place holding 1 there. So either method you use with either you thinking about them as landlords and you want to, make your tenants happy, or if you want to take the reciprocal of the base, either one works. Even if we go back to one of the ones we did up here, 4 to the negative 2, if you think about that, he's not happy where he's living. Where is he living? He's living in the numerator. If you want to make him happy, you can always just put him in the denominator, and then you still get that same answer in about the same number of steps, maybe a little bit less. On the next problem, I have -4 to the -2. If I wanted to, I could just say, oh, he's not happy where he's living. He was living in the numerator. Let's put him in the denominator. So we have 1 over -4 squared, which turns out to be 1/16. So you can do it either way. On the next problem, 2/5 to the -2, in order to get rid of the -2, in this case, the easiest thing to probably do here is just take the 2/5 and reciprocal them to make it a positive exponent. I think that's probably easier than thinking about it as tenants. Either way is fine though. We have 5 halves times itself 5 halves, which gets me 25/4. Alright, now on this problem, because we have two different bases here, when each of them have a negative exponent, I think the easiest way to think about this problem is like they're not happy. So 3 to the -2 is living upstairs. He's not happy about it, so you're going to move him downstairs. 4 to the -1, he's downstairs. He's not happy about it, so you're going to move him upstairs. So that leaves me with 4/9.